You can translate any reciprocal function horizontally or vertically, just as you can other functions. Take note, key concept, the reciprocal function family. Take note of the information on this slide, but we'll investigate these more in depth on the next few slides. First, the parent function, y equals 1 over x, where x does not equal 0, graphed here. A horizontal asymptote on the x-axis, or the line y equals 0, and a vertical asymptote, the y-axis, or the line x equals 0. Next, in the case of y equals a over x, where x does not equal 0, we have a stretch if the absolute value of a is greater than 1. An example graphed below, y equals 6 over x. We have a shrink if 0 is less than the absolute value of a, which is less than 1. We see an example graphed below. In this case, a is 0.25, and the function graphed is y equals 0.25 over x. Finally, a reflection across the x-axis if a is less than 0. An example graphed here is y equals -2 over x. Note, in this case, we have a reflection across the x-axis as well as a stretch by a factor of 2. And horizontal and vertical translations. In the case of y equals 1 over x minus some number h plus some number k, where x does not equal h, notice that would lead to a 0 denominator, we can see translations based on the values of h and k. A translation of y equals 1 over x by h units horizontally and k units vertically. An example is shown below. The equation y equals 1 over x minus 1 minus 2 is graphed. Consider the parent function shifted to the right 1 unit and down 2 units. Note the horizontal asymptote, which used to be the x-axis, has now shifted down 2 units, and the vertical asymptote, which used to be at the y-axis, is shifted to the right 1 unit. Now, in the case of y equals some number a over x minus h plus k, where x does not equal h, we have a translation of y equals a over x by h units horizontally and k units vertically. So in this case, graphed below, y equals -2 over x plus 1 plus 3. A reflection across the x-axis because of the negative in -2, a stretch by a factor of 2 because of the 2 in -2, a shift to the left, or translation left, 1 unit due to the x plus 1 in the denominator, and finally a shift upward 3 units due to the plus 3 on the right-hand side. The vertical asymptote of this translated function is x equals -1 due to the shift left of 1 unit. And the horizontal asymptote, which used to be the x-axis, is now y equals 3 due to the vertical shift upward 3 units. When you graph a translated reciprocal function, a good first step is to draw the asymptotes. Problem 3. Graphing a translation. What is the graph of y equals 1 over x plus 1 minus 2? Identify the domain and range. Step 1. Draw the asymptotes, shown here in red. Consider the parent function had asymptotes at each axis. Our translated function will have a vertical asymptote instead of being at the y-axis, exactly 1 unit to the left, due to the x plus 1, which translates the graph left 1 unit. And then our vertical asymptote, which used to be at the x-axis in the case of the parent function, is shifted down 2 units thanks to the -2 in the function. In terms of equations, we can state the vertical asymptote is x equals -1, and the horizontal asymptote is y equals -2. These serve as guides when graphing the function. Step 2. Translate the graph of y equals 1 over x. The graph of y equals 1 over x contains the points 1, 1 and -1, -1. Translate these points 1 unit to the left and 2 units down to the corresponding points 0, -1, and -2, -3, respectively. Draw the branches through these points and drawing infinitely closer to both the horizontal and vertical asymptotes. The domain is the set of all real numbers except x equals -1. The range is the set of all real numbers except y equals -2. Your turn. What is the graph of y equals 1 over x minus 4 plus 6? Identify the domain and range.